Hi, welcome back. Hope you are doing good. Now in this subsection 2.1 we are going to study about types of reactions. Okay, we all know that chemical reaction involves breaking and making of bonds between the atoms of reactants in order to form new products. Now in this section we will classify the reactions on the basis of how the atoms are rearranged in order to make a final product. So in this subsection 2.1 we are going to study about combination and decomposition reaction. So let's start with that. Now here we can see combination reaction. Okay, now again try to find literal meaning of this word combination. Now combination reaction and synthesis reaction. So you may get a question based on these two keywords, okay, and these two keywords give you the same meaning altogether. Okay, now talking about combination, so combination stands for the join or union of some entities. Okay, similarly synthesis, it is also the production of a substance by the union of chemical element. Okay, so in chemical reaction we would be combining the reactants in order to form a single product. So this is very important that you get only single product, you do not get any byproducts. Okay. Now this is the skeleton formula for this combination reaction. A plus B, which are the reactants, they are combined in order to form a single product. Now these reactants can be two or many reactants. Okay. Now these reactants can be two or more elements, two or more compounds, an element or a compound. So I believe that you know what are elements. So elements are made up of same kind of atoms, whereas compounds are made up of different kinds of atoms. So if you don't know about these, please go through the concept classes. Now we are going to understand these things in a much broader way. Now first is when reactants are two or more elements. So I told you that elements are basically made up of same kind of atoms. Okay. Now first part, burning of coal. So what is coal made up of? Coal is made up of carbon. Okay, and burning means it is reacting with oxygen. So we can say carbon when reacts with oxygen. So what it does, it gives you carbon dioxide along with the liberation of large amount of heat energy. Okay. Now we'll see if this equation is balanced. So carbon is one atom, oxygen is two atoms, so it is balanced. Okay. Now the next is burning of magnesium. Okay, so burning of magnesium, it's again same, the burning of magnesium strip we have studied before. So when magnesium reacts with oxygen, it forms magnesium oxide. Till this time this equation must be in your head now. Okay. Now when this reaction occurs, it emits UV rays. So we have to ensure that we make some use of some goggles, otherwise it can cause permanent eye damage. Okay, so it liberates light and heat energy. Okay, now we will see if it's balanced. So here oxygen is two atoms, whereas oxygen is one atom here. So I need to put 2 here in order to balance it. So I put it 2 here. Now magnesium is 2 atom here, so I need to put 2 here in order to balance magnesium. Okay. Now formation of water. So in order to form the water, hydrogen gas reacts with oxygen gas. Now let me tell you that hydrogen gas is highly reactive fuel. So it voluntarily reacts with oxygen with explosive release in the and water is also formed. So you have water here along with the liberation of large amount of heat energy. Okay, again we will see if it's balanced. It's not balanced, so we will put 2 here in order to balance oxygen. Now hydrogen is 4 atom, so we will put 2 here in order to balance these equations. Okay, so can you see that here every time you are getting only a single product along with the liberation of heat energy. Okay, now in this part 2 or more compounds react in order to form a single product. Okay, the first is formation of ammonium chloride. In this, what happens is ammonia, which is NH3, it reacts with hydrochloric acid in order to form ammonium chloride. The formula of ammonium chloride is NH4Cl along with the liberation of heat energy. Okay, now this ammonium chloride is basically dense white fumes. Okay. Now the second reaction is formation of slake lime. So this is one of the most important concept of this combination reaction. So sometimes the question is asked that how is the combination reaction used in a cement industry. So this is how you are going to write it. You are going to explain about the formation of slake lime. Okay. Now what happens is you have quicklime, which is CaO, calcium oxide. So when you add water to quicklime, you get to have slake lime. So the formula of slake lime is CaOH2 along with the liberation of heat energy. So it is such a vigorous reaction that the heat produced is very high. Okay. Now you may get the question that what is the substance which is used for whitewashing? So your answer has to be quicklime. So quicklime is the substance which you used for whitewashing. Okay. Now what happens is you take a drum, okay, and then you add calcium oxide to it. Okay. Then slowly you add water to it. Why slowly? Because it is very vigorous reaction. So if you put water all together, then it may bump out. Okay. So you have to put water slowly to this calcium oxide. Now what happens is this drum gets heated because it is highly exothermic reaction, and it forms what? It forms calcium hydroxide, which is slaked lime. Okay. Now you put the solution of slaked lime on the walls, and this slaked lime slowly reacts with the carbon dioxide present in the atmosphere in order to form calcium carbonate, which is called marble, okay, along with water. So now calcium carbonate is actually formed after 2 to 3 days of whitewashing. So this is one of the most important reaction which you need to consider for exams. Now next is the reaction between an element and a compound. Okay. So in this we are studying about formation of carbon dioxide from carbon monoxide. Okay. So carbon monoxide is CO and it is very flammable gas. So when it reacts with oxygen, what happens is it forms carbon dioxide along with the liberation of large amount of heat energy. So we need to see if it's balanced now. So if you see it's CO2, O is 3 atoms here, whereas it is 2 atoms here. So we need to balance it. Okay. So in order to balance it, if I put 2 here, then it would be oxygen will be 4. So if I put 2 here, then carbon will be 2 and oxygen will be 4. So we will be getting the balanced equation. So are you seeing one thing common in all the reactions? In every reaction, the heat energy is liberated. See, in every reaction. So we can see that multiple reactants are combining in order to give me a single product, and in every reaction heat energy is liberated, right? So we know that the reaction in which heat is given out are exothermic reaction. So in general we can say that most of the combination reaction, understand, I am not saying all of the combination, I am saying most of the combination reactions are exothermic reactions. Now you may ask that why these combination reactions are exothermic? So there are reasons for everything we have in science. Okay. So now combination reaction, it involves forming of bonds. Say suppose carbon and oxygen are combining. So when they combine as per their valencies. So they combine as per their valencies in order to become stable. Okay. So because bond formation actually represents a stable configuration for atoms, therefore it loses its extra energy in the form of heat, and that is why most of the combination reactions are exothermic. Okay. Now in the next topic we are going to study about decomposition reaction, which is actually the opposite of combination reaction. Now next is decomposition reaction. The decomposition reaction is basically the opposite of combination reaction, because here you have a single reactant in order to form multiple products. Okay. Now here what happens is, since you have to break down this compound which is there in the reactant, therefore energy has to be provided to it. So energy is provided in the form of heat or electricity or light energy. So we are going to study them one by one. So first is thermal decomposition. So what is thermal? Thermal means heat and decomposition means breaking up. Okay. So what will be thermal decomposition? It will be breaking of a compound with the action of heat. Okay, in this we are going to study about these examples: ferrous sulphate crystals, and number B calcium carbonate, and number C lead nitrate. So these three things will be decomposing. Okay, now ferrous sulphate crystal, the formula of ferrous sulphate crystal is FeSO4.7H2O. Now you must be thinking, what is this .7H2O? These are water of crystallization. So you will be studying about this in detail in further chapter. Okay, so as of now understand this, that these are ferrous sulphate crystals which are green in color. Okay, now when you heat it, what happens is, first of all, these 7 water of crystallization get lost. Okay, so you get only ferrous sulphate and this has been lost. Okay, so now what happens is, this ferrous sulphate is basically white in color. Now on further heating, they will break down into ferric oxide, which is Fe2O3 plus sulfur dioxide and sulfur trioxide. So actually you will have a smell of burning sulfur during this reaction. Okay, now this ferric oxide is basically brown in color. Okay, so you can also use this reaction in change in color. Now next is calcium carbonate. Now calcium carbonate is CaCO3. It is also called as limestone or marble. Now once you heat it, what happens is, it will decompose into what? It will decompose into calcium oxide, which is quicklime, and carbon dioxide. So whenever you have carbonate in reactant, always carbon dioxide gas will be released. Okay, now this quicklime is very much used in cement and glass industry. So you may get question on the basis of this. Okay, now the last is decomposition of lead nitrate. So what is the formula of lead nitrate? It is PbNO3 whole twice. So we know Pb is plus 2 and NO3 is minus 1, and that is why the formula comes out to be PbNO3. Now what we are going to do is, we will heat it. So once we heat it, we get lead oxide along with the liberation of gases, which is nitrogen dioxide plus oxygen. So these gases are released in the decomposition of lead nitrate. So this lead nitrate is basically colorless. It is a colorless compound, whereas lead monoxide, it is yellow color compound, and these nitrogen dioxide is basically brown fumes. Okay. So in every reaction we can see that we had a single reactant. So we had a single reactant here, if you see, here if you see, and here if you see, and we are getting multiple products. Okay, now our reactions is still not complete. We have to balance it. Here if you look for lead, so it is Pb, it is balanced. Talking about nitrogen, it is N2, whereas it is only single N. So first of all, what we will do is, we will try to balance oxygen. Okay, so if I put 2 here, so it will be 6 oxygen here, whereas there is also 6 oxygen. Okay, now we'll try to balance lead, because here if you see, it is 2 now in product. Now we need to put 2 here in order to balance it. Now if you see that nitrogen has become 4. Okay, for this I will have to put 4 here in order to balance nitrogen. So it is balanced equation now. Okay, now talking about calcium carbonate. So if we see, calcium is single atom here and calcium is single atom here. Carbon is single, carbon is single. Oxygen is 3, oxygen is 3. So this is a balanced equation. Now if you see about ferrous sulphate. Okay, so it is Fe, here it is FeSO4. You have single atom of iron, whereas here it is 2 atoms of iron. So if I put 2 here, in that way my iron will be balanced. My sulfur will be 2, sulfur will be 2, oxygen will be 3, 4, 5, 6, 7, 8, and here also oxygen is 8. So I am getting the balanced equation altogether. So now next is electrolytic decomposition. It means decomposition with the help of electricity. Now for this I have taken a beaker, and into this we have water and a small amount of sulfuric acid. So that is why this water will be called as acidified water. Okay. Now the question arises that why sulfuric acid is used? This is because water is a covalent compound and that is why it cannot ionize. So in order to make water a good conductor of electricity, we add sulfuric acid, but to a very small amount. Now we also have two conducting rods which are connected to a battery. So negative terminal is cathode and positive terminal is anode. To this we have inverted test tubes. Now what happens is when the electricity is passed, then you can see that a small amount of bubbles are getting collected inside these test tubes. So it means that water is breaking down into gases, and these gases are hydrogen gas and oxygen gas. Let us see the equations for the same. So now this is the reaction for electrolysis of water. So water breaks down into hydrogen gas and oxygen gas. Let me balance this. So if we put 2 here in order to balance this, so I will have to put 2 here. Okay, so these empty spaces here are representing the amount of gases collected. Okay, now we will see that the volume of gases collected in the two test tubes, suppose this is test tube number A and this is B. The volume collected in these two test tubes of the gases are not same. The volume of gas collected in the negative terminal, which is test tube number A, is double to the volume of gas collected in test tube number B. Okay, so in order to check what these gases are, we will be doing this small experiment. So what we are going to do is, we will bring the burning candle near to the mouth of the test tube first, which is test tube number A. Okay, so these bubbles will burst up with a popping sound, and we know that popping sound is produced by hydrogen gas. So we can say that in test tube A we have hydrogen gas. Okay, now when you bring the burning candle near to the mouth of test tube number B, then what happens is that the candle starts burning very rapidly. This means that the gas in this test tube supports combustion, and we know that the gas is oxygen, which supports combustion. So it means that in test tube A we have hydrogen gas, and the volume of this gas is double than that of the volume of gas in test tube number B. That is why we say that the ratio of hydrogen and oxygen collected during the electrolysis of water is 2:1. So this is one of the most important questions which can be asked in the exam. Now the next is photochemical decomposition, or the decomposition through light. In this we are taking an example of silver chloride and silver bromide. So we are going to decompose them. Okay. In the first example, we have a china dish in which we have kept silver chloride and it is exposed to sunlight. So after some time you will see that this white color is now changed with silver color. So what happens is, silver chloride on getting exposed to sunlight gets decomposed into silver and chlorine gas is liberated. Okay, so this silver chloride is basically white in color and the silver is basically grayish white in color. Okay, along with chlorine, which is yellowish green in color. Okay, so again this is a decomposition reaction because a single reactant is decomposing into two products, and this reaction is used in black and white photography. Now in second example we have silver bromide. So the silver bromide is basically yellow in color. Now when it is exposed to sunlight, then again it gets decomposed into silver and bromine gas. Now this bromine gas is reddish brown in color. Okay. Now what happens is, we need to balance it in order to follow the law of conservation of mass. Okay, so this is 2 here, so I'll put 2 here, then I'll put 2 here. Okay, now this is 2 here, so I'll put 2 here, and then I'll have to put 2 here. So yes, we have got the balanced equation. Okay, now let me tell you that most of the decomposition reactions are endothermic. Okay, now the question arises, why endothermic? This is because in every reaction we have seen, the energy is required in order to break the bond in between the reactants. Now if energy is required, it means that the energy has to be absorbed, and that is the work of endothermic. Okay, so the energy is absorbed in the form of sunlight or electricity or heat. So let me tell you, not all but most of the reactions of decomposition are endothermic. Okay, so congratulations, you have completed the topic combination reaction and decomposition reaction. So this is a takeaway point from this lecture. Okay, so combination reaction, only one product is formed. It involves making of bonds, and that is why these reactions are mostly exothermic reaction. Now talking about decomposition reaction, then only one reactant is there and it involves breaking of bonds, and that is why the energy is required in the form of heat, light and electricity. That is why most of them are endothermic. Now it's a time for think and write. Take a pause here and read these questions and try to find the answers to these questions and write in your own words. Okay, the first question is, when hydrogen gas burns in presence of oxygen, so it means H2 plus O2. Okay, so water is formed, H2O, and when water is electrolyzed, so H2 is electrolyzed, it means electricity is passed, then hydrogen and oxygen gases are produced. So state the kind of reactions that take place. So if you can see here, there are two reactants involved and a single product formed. So it would be a combination reaction in first case, whereas in second case only one reactant is there and multiple products are formed. That is why in the second case it would be decomposition reaction. Now the second question, explain giving chemical equations any two uses of chemical decomposition reaction in chemical industry. I hope so you have given the answer up to this question. Okay, it is very easy. We know that decomposition of calcium carbonate under the action of heat will give me what? It will give me quicklime, which is calcium oxide and carbon dioxide. Okay. Now this calcium oxide is widely used in cement and glass industry. Okay, next is decomposition of silver chloride by the action of light. Okay, it will give me silver along with the chlorine. Okay, so if I balance it, I'll put 2 here and I'll put 2 here. Now this reaction is used in black and white photography. Okay, now the third question. Okay, so what is the kind of reaction in digestion of food? So in digestion of food, the large macromolecules is broken down into simpler molecules. So it would be a decomposition reaction. Whereas combustion of coal means carbon is reacting with oxygen in order to give you carbon dioxide. Again, it will be a combination reaction. Okay. Question number 4. Why are decomposition reaction called opposite of combination reaction? This is because in decomposition reaction, you have a single reactant and it breaks down into multiple products, whereas in combination reaction you have multiple reactants and it gives you only a single product. Plus the decomposition reaction are basically endothermic because they absorb energy, whereas combination reaction are exothermic because they give out the energy. Okay, now you have to write equations for these reactions. So for the combination reaction you can just use this reaction itself. Okay, burning of coal, and for decomposition reaction you can use calcium carbonate decomposing, okay, into carbon dioxide and calcium oxide by the action of heat. So I hope so after going through the session these questions would have made pretty easier for you. Now I would meet you in the next session in which we will be going to discuss about single displacement reaction and double displacement reaction. Till then, bye bye and all the best.